Hello friends, today we are going to take some examples, 2 to 3 problems on Fourier series. So first problem is find the Fourier expansion of f of x is equal to 4 minus x square in 0 is less than x is less than 2, and same problem is find Fourier series for f of x is equal to 2x minus x square in 0 is less than equal to x is less than equal to 3. So I am explaining first problem, you try second problem at your own level. Okay, so first we have to find Fourier series of f of x is equal to 4 minus x square in 0 is less than x is less than 2. So here f of x is 4 minus x square and interval is 0 is less than x is less than 2. In problem find Fourier expansion and not half range. Interval is 0 to 2, so that's why I am explaining here. Question is find Fourier expansion of f of x, means this problem is on full range Fourier series. So 0 is less than equal to x is less than 2, means that is 0 to 2l interval. 0 to 2 means equate with 0 to 2l. And suppose this problem is for half range, means find half range cosine series or half range sine series, then take interval 0 to l. In half range take 0 to l, in full range take 0 to 2l. So what is 2l here? 2l is equal to 2, so l is equal to 1. This is very important. And interval is 0 to 2l, so no need to check here whether f of x is even or odd. So when we check f of x is even or odd, if interval is minus l to plus l. Now what is the value of l here? L is equal to 1. So if interval is 0 to 2l, then how we write its Fourier series expansion? So formula is f of x is equal to a0 by 2 plus summation of n varies from 1 to infinity an cos n pi x by l plus bn sin n pi x by l. So we have to find here all three coefficients a0, an and bn, and put l equal to 1. Now we will find one by one. So first one is a0 is equal to a0 is 1 by l into 0 to 2l. This is the formula, 0 to 2l f of x dx. Okay, so what is the value of L? L is 1, so is equal to 1 upon 1 into integration of 0 to 2, 0 to 2L, 0 to 2L, value of 0 to 2L is 0 to 2, and f of x is 4 minus x square into dx. Now what is the integration of this? Integration of 4 is 4x minus integration of x square is x cubed by 3, limit is 0 to 2. Now put here upper lower limit. If you put upper limit x is equal to 2, so 4 into 2 is 8 minus 2 cube is 8 by 3, lower limit is 0. So 8 into 3 is 24 minus 8 by 3. So 24 minus 8 means that is 16 by 3. So this is the value of a0. a0 is 16 by 3. Similarly, we have to find, means denote this by 2, say finally we have to put this 2 in 1. Then we have to find an. So what is an? Again formula is 1 by l integration of 0 to 2l f of x cos of n pi x by l into dx. But l is 1 here, so if you put l equal to 1, then 1 by 1, 0 to 2, f of x is 4 minus x square into l equal to 1, so cos of n pi x dx. Now how we take integration? Again using generalized rule of integration by parts. So take u is equal to 4 minus x square, v is equal to cos n pi x. So using integration by part, u write as it is, that is 4 minus x square into integration of v is sin n pi x upon n pi. Then next step is take alternate sign and take derivative of first term, integration of second term. So derivative of 4 minus x square is minus 2x into integration of sine is minus cos n pi x upon n pi into n pi, that is n square pi square, plus derivative of this term is minus 2 into integration of minus cos is minus sine n pi x upon n pi into this, that is n cube pi cube, and limit is 0 to 2. Now put here upper lower limit. So if you put upper limit x is equal to 2 here, so we get 2 square is 4. So 4 minus 4 is 0. Here 3 times minus sign a, that is minus x is equal to 2. So 2 into 2 is 4 into cos of 2n pi upon n square pi square, and here minus minus plus x equal to 2 sine 2n pi. Sine n pi is 0 for all values of n. Similarly, if we put x is equal to 0 lower limit here, so 4 minus 0 is 4 into sine 0, that is 0. Here 3 times minus lower limit minus, that is plus, but x is multiple, so if you put x equal to 0, 0 into cos 0 is 0. Here 2 times minus, that is plus, and lower limit minus sine 0 is 0. Okay, and what is the value of cos 2n pi? Cos 2n pi is 1. So the value of an is minus 4 upon n square pi square. This is equation 3. After an we have to find bn. Now how we write bn? So formula a, bn is equal to 1 upon l, so l is 1 here, into integration of 0 to 2l, so 0 to 2, f of x, that is 4 minus x square into sine n pi x by l, l is 1, into dx. And for integration again you have to use here u into v rule, so u equal to this, v equal to this. So how we write integration? U v1 minus u dash v2. Okay, so you write 4 minus x square as it is, into integration of sine is minus cos of n pi x upon n pi, minus u dash means derivative of first term, integration of second term. So derivative of first term is minus 2x into integration of minus cos is minus sine n pi x upon n pi into n pi, that is n square pi square, plus derivative of minus 2x is minus 2 into integration of minus sine is, integration of sine is minus cos, so minus minus plus cos of n pi x upon n pi into this, that is n cube pi cube, and limit varies from 0 to 2. So put here upper lower limit. If you put upper limit x is equal to 2, so 2 square is 4, 4 minus 4 is 0 here. 3 times minus sign minus, so x equal to 2, again sine 2n pi is 0. Here minus sign a, minus 2 into cos of 2n pi upon n cube pi cube. Lower limit x equal to 0, if you put here this minus, lower limit minus, that is plus, 4 minus 0 is 4 into cos 0 upon n pi, and here 3 times minus, lower limit minus, that is plus, but sine 0 is 0. Here minus a, lower limit minus, that is plus, 2 into cos 0 upon n cube pi cube. So after simplification, we know that cos 2n pi is 1, so this is minus 2 upon n cube pi cube, plus 4 upon n pi, that is cos 0 is 1, and plus 2 upon n cube pi cube, so is equal to, so 2 upon n cube pi cube get cancelled, so bn is equal to 4 upon n pi. This is equation 4. Now we have to write required Fourier series of this function f of x is equal to 4 minus x square in the interval 0 is less than x is less than 2. So that Fourier series is f of x equal to this. So in this we have to put a0, an and bn. So from equation 2, a0 is 16 by 3. Then an is from 3 minus 4 upon n square pi square, and bn is 4 upon n pi, put in 1. And therefore required Fourier series of f of x in the interval 0 is less than x is less than 2 can be written as f of x is 4 minus x square. So 4 minus x square is equal to 4 minus x square is equal to a0 by 2. Now what is the value of a0? A0 is 16 by 3. So 16 by 3 upon 2 plus summation of n varies from 1 to infinity an from equation 3, that is minus 4 upon n square pi square into cos n pi x by L. So n pi x, L is 1, plus bn is 4 upon n pi into sine n pi x. So after simplification, this is 8 by 3, 16 by 2 means 8 by 3 plus summation of n varies from 1 to infinity minus 4 means we can take this 4 outside series or write as it is minus 4 upon n square pi square cos n pi x plus 4 upon n pi sine n pi x. So this is the required Fourier series for the function f of x is equal to 4 minus x square in the interval 0 to 2. So same, next problem is same here, that is find Fourier series for f of x is equal to 2x minus x square in the interval 0 is less than equal to x is less than equal to 3. So you try this at your own level. If you have any doubt, you can comment on comment section. Okay, now we will take next problem. Next problem is determine Fourier expansion for f of x is equal to 0 if minus 2 is less than equal to x is less than equal to minus 1, 1 plus x minus 1 is less than equal to x is less than 0, 1 minus x, 0 is less than equal to x is less than 1, and 0, 1 is less than equal to x is less than 2. So period given here 2L. So period is 2L. 2L is equal to, means period is 4 here. So 2L equal to 4 means the value of L is 2 here. And interval is minus 2 to plus 2 means that is minus L to plus L. From this also we can write L equal to 2. So interval is minus L to plus L. We have to check given function is even or odd. So in minus 2 to minus 1, 0 given is. So 0 is always even function because that is constant function. Here also 0, this is constant. So we have to check only 1 plus x and 1 minus x is even or odd in the interval minus 1 to 0 and 0 to 1. So this is also minus 1 to plus 1. So how we check? By putting x equal to minus x. So f of minus x is equal to here if you put x equal to minus x, then we get 1 minus x, and in interval minus 1 is less than equal to minus x is less than 0. So minus 1 is less than equal to minus x is less than 0, but we want here positive x. So if you multiply throughout by minus 1, then minus become plus and less than become greater than. So this can be written as 1 is greater than or equal to, means minus 1 से multiply किया तो less than का conversion होता है greater than में. So 1 is greater than equal to x is greater than 0 means 1 minus x, 0 to 1. And second one means what is this? This is f of x, means we get f of minus x is equal to 1 minus x. For 0 is less than equal to x is less than 0 is less than or x is less than equal to 1. And second one, if you take suppose f of x equal to 1 minus x first, in that also if you put x equal to minus x, then here minus minus plus, that is 1 plus x, and 0 is less than equal to minus x is strictly less than 1, can be written as 0 is greater than equal to x is greater than minus 1, means minus 1 to 0. In minus 1 to 0, f of x given a 1 plus x, so this is equal to f of x, means in both we get f of minus x equal to f of x. So from this we can say that f of x is an even function. If f of x is even, then we know that bn is always 0. So we have to find only a0 and an. So Fourier series expansion is f of x is equal to a0 by 2 plus summation of n varies from 1 to infinity an cos n pi x by L. So to find only a0 and an here. So even function is, so how we write a0? A0 is equal to 2 by L, 0 to L f of x dx. But what is L? L is equal to 2 here. So that is equal to 2 by 2 integration of 0 to 2 f of x dx. Now in 0 to 2, 0 to 2 means observe these four intervals. Interval is minus 2 to 2 given. In that our limit is only 0 to 2. So in 0 to 2 means we have to use only this function 0 to 2. In 0 to 2 we have to split in two parts, 0 to 1 and 1 to 2. So is equal to get cancelled, 0 to 1. In 0 to 1, 0 to 1 f of x given a 1 minus x. So 0 to 1, 1 minus x dx, and plus 1 to 2, 1 to 2. In 1 to 2 f of x given is 0. So 0 into dx. Now take integration of this. Integration of 1 is x and integration of x is x square by 2. Limit is 0 to 1. So if you put upper limit x equal to 1, 1 minus 1 by 2 minus 0 minus minus plus 0 is equal to 1 by 2. So a0 is 1 by 2. Similarly, we have to find an here. An is equal to, formula is again 2 by L. So L is 2 here, into integration of 0 to 2 f of x cos of n pi x by L, n pi x by 2 into dx. Okay, so again 2 to get cancelled. So 0 to 2 we have to split in two parts, 0 to 1 and 1 to 2. So integration of 0 to 1, in 0 to 1 f of x given a 1 minus x into cos of n pi x by 2 dx, and plus 1 to 2, in 1 to 2 f of x given is 0 into cos of n pi x by 2 into dx. So next value of next integral is 0. So how we take integration of this? Using u into v. So u equal to this, v equal to this. So u, that is 1 minus x into integration of cos is sine of n pi x by 2 upon n pi by 2, minus derivative of this term is minus 1 into integration of this sine is minus cos of n pi x by 2 upon n pi by 2 into this n pi by 2, that is n square pi square by 4. And next one is derivative of this term is 0. So stop here, limit is 0 to 2. Now observe this term carefully. If you put x is equal to 2 here, 1 minus 2 is minus 1. Then here x is equal to 2, 2 to get cancelled. So sin n pi, and sin n pi is 0. So first term is 0. 3 times minus sin a, that is minus cos a. So if we put x is equal to 2, then this denominator first, right, that is 4 upon n square pi square. And here if we put x is equal to 2, then we get cos n pi, means 2 to get cancelled. Lower limit x equal to 0, sin 0 is 0. Here 3 times minus, lower limit minus, that is 4 times minus sign, that is plus. First write denominator 4 upon n square pi square into cos 0. So we know that cos n pi is minus 1 raised to n and cos 0 is 1. So if we can take this 4 upon n square pi square common, in bracket here cos 0 is 1 and cos n pi is minus 1 raised to n. So this is the value of an. Now put this an and a0 in equation 1, that is our final answer. Means that is the Fourier series expansion of f of x in the interval minus 2 to plus 2. So you put the value of a0 here, that is 1 by 2 upon 2, that is 1 by 4, plus summation of n varies from 1 to infinity. An is 4 upon n square pi square into cos of n pi x by 2. So this is the final answer of this problem. Now next problem is obtain the Fourier series expansion for the function f of x given by f of x equal to 1 plus x if minus 1 is less than equal to x is less than equal to 0, and 1 minus x if 0 is less than equal to x is less than equal to 1. So this problem is same as last problem. Means here interval is minus 1 to plus 1. So we have to check given function is even or odd. I think this problem and last problem is same. So no need to solve this, because in last problem here function was f of x equal to 1 plus x minus 1 to 0 and 1 minus x 0 to 1. Same here, 1 plus x if minus 1 to 0 and 1 minus x if 0 to 1. So solution is same, only difference is here. Here interval is minus L to plus L equate with minus 1 to plus 1. So L equal to 1 here. Here L is 1. Okay. So In last problem L is 2, so only take L equal to 1 and use same concept. Take the help of this problem, check whether this function is even or odd. This is even function, so Bn is always 0. Only find a0 and an by taking L equal to 1. Okay, सो यदि आपने सब्सक्राइब नहीं किया है तो चैनल को सब्सक्राइब कीजिए। कुछ डाउट है तो कमेंट सेक्शन में बताइए। थैंक यू।